Hi guys, this is our next video, and our next video is going to be over electron configurations, the rules that govern for electron configurations, and also these 4 quantum numbers that Schrodinger talks about with his electron cloud model. Now what I care about is that you know 2 of those 4, because when we take AP Chemistry next year we're going to focus on all 4 of them, and we'll go more in depth with them. But right now I care about 2. So the first thing is, Schrodinger has to ask himself, what is an energy level? And you know that an energy level is just the region around the nucleus that we are more likely to find an electron. So you know that there is a certain probability that corresponds with that of how likely we are to find an electron, and that would be 90%. So what is an energy level? You already know that. Again, region around the nucleus where we are 90% likely to find an electron. The quantum mechanical model designates these energy levels by something else. They call it a certain name. So Schrodinger called energy levels principal quantum number. So it's just another name for energy levels, okay? Same thing. It's just interchangeable. It's just like how we can call a column or family on the periodic table a group. We can call energy levels by principal quantum number. Now, we give that a symbol. So instead of saying principal quantum number, instead of writing out principal quantum number, I could just write the letter N. And N just means energy level or principal quantum number. So again, interchangeable. Principal quantum number is the energy level of the electron. We know how to find our energy level by looking at our periodic table. You know that the first energy level represents the first row of the periodic table. I know the second energy level represents the second row of the periodic table. Third energy level, third row. Fourth energy level, fourth row. Fifth energy level, fifth row, so on and so forth. With principal quantum number, if I were to ask you a question like, N is equal to what when you're in the third row? You would write N equals 3, because principal quantum number or energy level is symbolized by N. So if I'm in the third row, N would equal 3. If I'm in the first row, N would equal 1. If I'm in the second row, N would equal 2. Okay? So this is the first of 4 quantum numbers that Schrodinger worked out. And he did this all with mathematics, but again, we're not focusing on that in this class. So principal quantum number is the first quantum number, and it tells you, or tells us, what energy level an atom or an electron is in. So principal quantum number, energy level, same thing. The second quantum number is called the angular momentum quantum number, and that is symbolized by the letter L. So angular momentum quantum number, which right now you're like, oh my gosh, what does that mean? Stick with me. So second quantum number is angular momentum quantum number, and we symbolize that with L. All angular momentum means, in terms of this quantum number, is what shape the electron cloud will be. That's it. It's just what shape it will be. So it says on here, within each energy level, complex math of Schrodinger equations describes several shapes. So we're not always going to see an electron cloud as a circle or a spherical. Sometimes it can look like a clover leaf. Sometimes it can look spherical. Sometimes it could look like a dumbbell. It's going to change depending on where we are on the periodic table. So these shapes that the electron cloud can make, we call these atomic orbitals. You will also hear them called sublevels, and there are 4 of them. So let's go back. Principal quantum energy, or principal quantum number, just means energy level. We symbolize that with N. I know that. I can find that using my periodic table based on what row I'm in. Angular momentum quantum number, we symbolize that by L, and all that means is what is the shape of the electron cloud. That's it. Again, I'll call them shapes. I will call them atomic orbitals, or I will call them sublevels. So all of those words can be used interchangeably. Let me show you what I mean by these 4 sublevels. Now today, I gave you a blank periodic table that I wanted you to look at or use while you're watching this video. So you see that there are 4 sections of where we can see these different shapes, and we give these different shapes a letter that corresponds with them. So these 2 columns here, the first 2 columns on your periodic table that are labeled 1A and 2A, these would be my alkaline metals, those would be my alkaline earth metals. This is the S sublevel. So right now on your periodic table, I would want you to label those 2 columns as being S. Now you'll see right next to it, when L is equal to 0, that means that you're always talking about the S sublevel. Or it's going to have an S, I don't want to say an S shape because it doesn't look like an S, but it's going to have a certain shape, okay? If I go over, let's look at where my transition metals are. My transition metals are their own type of shape, or I'm going to see a different type of shape with them, and we call this the D sublevel. So first 2 columns would be the S sublevel, or atomic orbital. The transition metals, we call these the D orbital, or we'll say the D sublevel. When L is equal to 2, that means that that electron, or the atom, can be found in the D sublevel, okay? That means it's going to be somewhere in here within my transition metals. If I go over to here, I have 6 more columns over here, and we call that the P sublevel, or the P atomic orbital. Now when L is equal to 1, I know that I'm in the P orbital, and that's just somewhere over here on my periodic table, okay? Last 2 rows, or the last sublevel, because remember we said there are 4. The last sublevel that we have is F, and those are the 2 rows on the bottom. Those are the rare earth metal, that's the rare earth metal or rare earth elements family. And that we call the F sublevel, and when L is equal to 3, that's when we know that we're in the F orbital, okay? So when L equals 0, we're in the S orbital, or S sublevel. And that means that we're within these 2 columns. When we're in the D orbital, that's when L equals 2, that means we're somewhere here within the transition metals. When we're at L equals 1, that tells us we're in the P suborbital, so that means we're somewhere in here in these 6 columns. And when we're on the F orbital, that means that L equals 3, and that means that the electron is found, or the atom is found, somewhere in these bottom 2 rows here, okay? So make sure that you draw or label on your periodic table S, the first 2 columns, D, the transition metals, P, that would be 3A through 8A, and then the rare earth metals would be F, okay? So again, angular momentum, quantum number, symbolizes L, and that just tells me what shape my electron cloud will look like. And there are 4 possible shapes that I could have. There's a shape that will be designated for the S sublevel, there's a shape that will be designated for the P sublevel, one for the D, and one for the F. So we have 4 sublevels. We're going to call those S, P, D, and F. What we just said, each sublevel has a different shape. Now, today I also gave you a paper with all of these different pictures on them. So let's look at those pictures right now. If you would look at the very top row, I see that I have S here, and my S is spherical. So would you write down for me, the S sublevel is spherical in its shape. That means the electron cloud looks like a circle. It looks spherical. So S will always have a spherical shape. The electron cloud will always have a spherical shape. If you look at the P sublevel, that's columns 3A through 8A. And if you look on your paper, I drew what those electron clouds will look like. Well, chemists would say that these kind of look like dumbbells, so we say that the P sublevel has a shape of a dumbbell. Okay, and I have that written here. The P sublevel is shaped like a dumbbell. Now, if we go down to the very 3rd row on your little pictures or on your drawings, you have 5 different shapes here. Now, for the most part, kind of avoid this DZ squared because this shape is just kind of random and out there. But the other shapes, we can say they look like clover leaves. So we would say that the D sublevel, or the D subshell, looks like a clover leaf. So those are the shapes that these electron clouds will typically take when an electron is found in one of those specific orbitals or specific sublevels. The other two quantum numbers that Schrödinger worked on, one was called the magnetic quantum number. We designate that by the symbol M. I don't care so much that you know about that. The only thing I care about is that you can just say it indicates the orientation of the orbital. So if you look on your paper, you see that S only has one type of orientation because there's only one little shape here on the S. You see that on P, there's 3 different shapes. It could be X, Y, or Z. So that means that it could have like 3 different orientations. On D, there's 5 different shapes. That means that you can have 5 different orientations. That's all that means. The fourth quantum number is called the spin quantum number. And the spin quantum number has 2 values. You can either have a spin of a positive half or a minus half. And all I care about right now is that you just know that a spin quantum number means that it could be plus 1/2 or minus 1/2. And you're going to see exactly what I mean in just 1 second, okay? So let's do a summary of these sublevels and talk about their shapes, their maximum electrons, and all of those things. So the S sublevel I can find on the periodic table by looking at the first 2 columns, 1A and 2A. I know that it can only have one shape. It's one sphere. That's it. I can't make a sphere look any different, right? No matter how I turn a sphere, it's going to look the same. So I only have one shape for the S. So that means I have one shape or one orbital. In this orbital, I can hold a maximum of 2 electrons. So in these shapes, I can hold a maximum of 2 electrons. This should make sense to you. If you look at where lithium and beryllium are, this would be the first column in S, and then beryllium would be the second column in S. So lithium would hold the first electron, beryllium would be the second electron. If I go down to sodium and magnesium, sodium would be the first electron, magnesium would be the second electron. I only have 2 columns in the S subshell, or in the S sublevel. So that means it can only hold up to 2 electrons because I only have 2 columns. Now, we know that the S sublevel would start on the first energy level because I know that hydrogen is part of that S sublevel, and hydrogen being part of that S sublevel is in row number 1. So I know that the energy level would just be row number 1. If I go to P, if we go to the P sublevel, if we look at the P sublevel, we see that there are 6 columns in that P sublevel. If you look at your paper, you have 3 different shapes on your paper, 3 different ways that you can orient that dumbbell shape. So I have 3 shapes on my paper. That means that I have 3 orbitals because there are 3 shapes. The maximum number of electrons, if I count each one of those elements in those 6 columns, each element represents an electron. So if I have 6 elements, or 6 columns in that row, that means that the maximum number that it can hold would be 6. So that means that each one of these drawings, I had 3 drawings, each one can hold a maximum of 2 electrons. So if I went all the way through that row, I could have 1, 2, 3, 4, 5, 6. All 6 of the elements would be represented. Let's just skip this last one for just a second. Okay, D. If I look on my paper, how many shapes of D do I have? I have 1, 2, 3, 4, 5. I have 5 shapes for D. So that means I have 5 shapes or 5 orbitals. If I count in the D, if I count all of the D columns, I go from 21 to 30. So that means I have 10 columns, vertical columns, in the